So let's go with the remaining questions. So let's start with question 12. So according to the third law of motion, when we push an object, the object pushes back on us with an equal and opposite force. If the object is a massive truck parked on the roadside, it will probably not move. Right? A student justifies this by answering that the two opposite and equal forces cancel one another. Comment on this logic. Explain why the truck does not move. Okay. So the student says that that there is a huge truck. And the student tries to push that truck. And the student says that because I'm pushing the truck, it is an action, and there is an opposite reaction, and these two cancel each other, and that is why the truck is not moving. Now, is that the real reason? Not really, right? Because what the student is trying to answer is by Newton's third law of motion, which means that every action has an equal and opposite reaction. So when object A applies a force, exerts a force on object B exerts a force on object A. So the force acts on different objects. It's not on the same object, right? A acts on B and B acts on A, right? So there is nothing to cancel, right? So it doesn't get cancelled. What gets cancelled is only when two opposing forces act on the same object, right? So in case of Newton's third law, it is A acts on B, B acts on A. It's on different objects. So that is not the reason here. So what is the reason? It's probably because the truck is huge and the amount of force that is applied here is not able to overcome the frictional force provided by the floor or the road, right? The net the force that is being applied by the student is actually balanced by the frictional force, and that is why the truck is not moving. And the truck will only move when you when you apply enormous force, so that your net unbalanced force is non-zero. Only then the truck will start to move, right? So the reason why the truck is not moving here is not because of Newton's third law. It is because the force with which the truck is pushed is actually being balanced by the frictional force. A hockey ball of mass 200 grams traveling at 10 meters per second is struck by a hockey stick so as to return it along the original path with a velocity of 5 meters per second. Calculate the magnitude of change of momentum occurred in the motion of the hockey ball by the force applied by the hockey stick. Okay. So in this case, we are talking about a hockey ball which is which has a mass of 200 grams, and it was traveling with the velocity of 10 meters per second. So the initial speed, let's consider the initial velocity to be UA, which is 10 meters per second, and the mass is 0.2 kilograms, which is 200 grams. So when this was traveling at a speed of 10 meters per second, it was struck by a hockey stick, which sent the ball back in the same direction, in the original path, but in the opposite direction. So it basically hit the stick and then it came back, right, with a different velocity, and that velocity is 5 meters per second. So the final velocity after hitting the stick is minus 5 meters per second. Why is it minus? Because it is in the same path but in the opposite direction, right? So given this, what is the change in momentum? So the change in momentum is momentum. We know that it is mass times velocity, right? So after being struck, the momentum is ma times va, and before being struck by the hockey stick, the momentum is ma times ua, right? So when you apply this formula, you will get to see that your mass is 0.2 times minus 50, and which is equal to minus 3 kilograms meters per second. So that is the change in momentum, and the magnitude of the change in momentum is excluding the direction, which is just 3 kilograms meters per second. Question 14. A bullet of mass 10 grams traveling horizontally with a velocity of 150 meters per second strikes a stationary wooden block and comes to rest in 0.03 seconds. Calculate the distance of penetration of the bullet into the block. Also calculate the magnitude of the force exerted by the wooden block on the bullet. Okay. So in this case, you have a stationary wooden block, and the bullet hits the wooden block, and when it hits, just at the moment it hit the wooden block, it was traveling with a velocity of 150 meters per second, but after striking it, it came to rest in 0.03 seconds. So it basically went inside for some distance, and then after 0.03 seconds, it made a full stop, right? So just to get the variables right, so the initial velocity of that bullet is 115 meters per second. Initial velocity is just at the moment when it touched the horizontal block. The final velocity is of course 0 meters per second, and the time taken is 0.03 seconds, right? So with this, you know the acceleration. You can find the acceleration encountered by the bullet, which is a negative acceleration because the velocity reduced to 0, right? So it is going to be a final velocity minus the initial velocity by 0.03, and which is equal to minus 5,000 meters per second square. Now, if this is the case, if this is the acceleration, the force exerted by the bullet is going to be minus 5,000 times the mass of the bullet, which is 10, right? So if that is the force exerted by the bullet on the wooden block, which is minus 5,000 times 10 grams. But the question is, what is the magnitude of the force exerted by the wooden block on the bullet? So the force exerted by the block on the bullet is going to be 5,000 meters per second square, and which is negative of this, actually negative of minus 5,000. And since the question is only we need to know the magnitude, it has got to be converting this into kgs would be like 50 kilograms meters per second square, which is derived from the mass of the bullet, which is 0.01 times the acceleration here. Question 15. An object of mass 1 kg traveling in a straight line with a velocity of 10 meters per second collides with and sticks to a stationary wooden block of mass 5 kg. Then both move off together in the same straight line. Calculate the total momentum just before the impact and just after the impact. Also calculate the velocity of the combined object. Okay, so an object of mass 1 hits hits a stationary wooden block, right? So let's consider the first object to be A, and the mass is mass MA is 1 kg. Let's consider the wooden block to be B, which means that the mass of the wooden block is 5 kg. Now let's consider the initial velocities of because it is colliding, both the objects are colliding. Let's consider the initial velocities. UA, the initial velocity of that object was 10 meters per second, right? And the initial velocity of the wooden block, we knew that the wooden block was stationary, so the initial velocity UB is 0, right? Now the question here is to find the total momentum just before the impact and just after the impact, right? So which means that let's find out, we don't know the final velocity with which both of them travel. We knew that both the objects after colliding, they traveled together in the same straight line, right? So we don't know their velocities, what they are, but we only know that they travel together, which means that the final velocity VA of object A and VB of object B is going to be the same. Let's consider that as V, right? Now from this, we know that from the law of conservation of momentum, we knew that the sum of the initial momentum before collision is equal to the sum of the final momentum after collision, right? Now in this, we knew that we have access to all the variables except for VA and VB, and we can replace both of them by V, right? And which means that with this we can solve for V, the value of V, which is going to be equal to 1.67 meters per second. So yeah, so that is going to be the final that is going to be the velocity of the combined object. So both of them traveled with a speed of 1.767 meters per second. Both objects traveled together. Question 16. An object of mass 100 kg is accelerated uniformly from a velocity of 5 meters per second to 8 meters per second in 6 seconds. Calculate the initial and final momentum of the object. Also find the magnitude of the force exerted on the object. So here we know that the object of the mass is 100 kg. So let's consider the mass is 100 kg. The initial velocity u is 5 meters per second. The final velocity v is 8 meters per second, and we knew that the time taken is 6 seconds. So what is the initial momentum? Momentum is mass times the initial velocity. That is your initial momentum, which is 100 into 5, which is 500 kg meters per second. So that's the initial momentum. Final momentum is mass times the final velocity, which is 8 meters per second. So it is going to be 100 times 8, which is 800 kilograms meters per second. So that's the final momentum of the object. Also find the magnitude of the force exerted on the object. So we know that the force is mass times the acceleration. So how do you know the acceleration? Acceleration is the difference in velocity, right? V minus u over t. So we know that v is 8 and u is 5. So the acceleration is 3 over 6. It's 6 seconds. So force is 100 into 3 times 6, which is equal to 50 newtons. Right? So that's the magnitude of the force is 50 newtons. Akhtar, Kiran and Rahul were riding on a motor car that was moving with high velocity on an expressway when an insect hit the windshield and got stuck on the windshield. Akhtar and Kiran started pondering over the situation. Kiran suggested that the insect suffered a greater change in momentum as compared to the change in momentum of the motor car, because the change in the velocity of the insect was much more than that of the motor car. Akhtar said that since the motor car was moving with a larger velocity, it exerted a larger force on the insect, and the result, the insect died. Rahul, while putting an entirely new explanation, said that both the motor car and the insect experienced the same force and the change in their momentum. Comment on the suggestions. Okay. So I think the trick here is that the car is the mass of the car is very high. The mass of the car is much higher than the mass of the insect, right? So that is what could have we can tend to get confused because of that. But the fact is that consider these two as simple objects, irrespective of the mass. Newton's laws applies to objects of any mass, however heavy and however small. So when two objects collide, it means that when the car, be it the car or the insect, when they hit one another, at the time of collision, Newton's third law would apply, which means that the force exerted by the insect on the car is going to be exactly the same as the force exerted by the car on the insect. That is Newton's third law. So there is which means that your law of conservation of momentum will hold good. And your sum of the initial momentum is always going to be equal to the sum of the final momentum. So there is no way that the car is going to exert a higher force on the insect just because it is heavier. That is not going to happen. The force is exactly the same per Newton's third law, and which means that both the motor car and the insect would have experienced the same force and the same change in their momentum. So, in a sense, Rahul was right, and Akhtar's understanding is incorrect in this scenario. How much momentum will a dumbbell of mass 10 kg transfer to the floor if it falls from a height of 80 centimeters? Take its downward acceleration to be 10 meters per second. Okay, so in this case, the object is not moving from A to B on a horizontal path, but it is moving on a straight line, on a vertical path, right? So the dumbbell mass is 10 kgs, and when it starts, the initial velocity is 0, right? And it covers the distance of 80 centimeters. So S is 80 centimeters, which is 0.8 meters, and the acceleration that it has encountered is 10 meters per second squared. Now the question is, what is the momentum? So momentum is mass times the velocity, right? So the question is the momentum at the time the dumbbell hits the floor, right? So which means that we need to know the final velocity of that dumbbell at the time it hits the floor. So which means that we'll have to find v, which is the final velocity, and we can derive that from the third equation of motion. because you have acceleration and distance. So 2af equals v square minus u square, and which means that you can derive v to be 4 meters per second. Once you have v, the momentum is just mv, which is your mass is 10 kgs and your velocity is 4, so it is going to be 40 kilograms meters per second. So I think we have completed the exercise, but there are some additional exercise questions. There are just 4 of them. Let's go through them as well. The following is a distance time table of an object in motion. So what is given in the table is, at every time what is the distance that is covered. So write a time 0 seconds, the distance covered was 0. The object is just a good. So after 1 second, the object covered 1 meter. After 2 seconds, it covered 8 meters. After 3 seconds, it covered 27 meters, and so on. The question is, what conclusion can you draw about this acceleration? Is it constant, increasing, decreasing, or 0? Right? And what do you infer about the forces acting on that particular object? So let's calculate the difference, right? So this is the time in seconds, and this is the distance in meters, right? So what is the velocity at every second? So velocity is the distance traveled by the time, right? So between 1 second, between 0 and 1, the velocity was 1 meters per second. Between 1 second and 2 seconds, the velocity was 7 meters per second, because the velocity increased from 1 to 7. It acquired 7. It was able to cover an additional distance of 7 meters in the second, right? So that is where it became 8. So when it was 3 seconds, it was able to cover an additional 19 meters. Right, and when it was 4th second, it was able to cover another additional 37 meters, and we can only see that the increase in velocity, there is an increase in velocity after every unit time, which is every second. So when the velocity increases every unit time, which means that the object is accelerating, which means that there is an increase in acceleration. The acceleration is also not constant here, because the velocity is increasing. The rate of change of velocity is not constant here, right? The rate of change of velocity is increasing. Between here it is between 7 and 1 it is 6, but here it is 12, and here it is higher. So it is an increasing acceleration. It's not a constant acceleration, nor a decreasing acceleration, nor zero acceleration. It is an increasing acceleration. That's very clear. What do you infer about the forces acting on the body? Because it is increasing acceleration, it means that the object, the forces, there is a net non-zero unbalanced force that is acting on that object, right? There is a net unbalanced force on that object. Only then the object will begin to accelerate, right? If the net unbalanced force is 0, then the object will only move with a constant velocity, right? So in this case, because it is accelerating, it means that there is a net unbalanced force that is acting on this body. 2 persons managed to push a motor car of mass 1200 kgs at a uniform velocity along a level road. The same motor car can be pushed by 3 persons to produce an acceleration of 0.2 meters per second. With what forces does each person push the motor car? Assume that all the persons push the motor car with the same muscular effect. Okay. So 3 people are pushing the car, and when the 3 of them push the car, it acquires an acceleration of 0.2 meters per second. So the understanding here is that all the 3 have the same ability, right? In terms of the force that they exert on the car. So which means that if the force exerted by 1 person is considered to be F, the force exerted by 3 people on the car is going to be 3F, right? Now that is a total force that is exerted on that car. Now when 3F force is applied, we knew that the car undergoes an acceleration of 0.2 meters per second, which means that 3F equals 1200, which is the mass of that car, times 0.2 meters per second square. Now with this we can solve for F, which comes down to be 80 newtons. So 80 newtons is the force applied by 1 person, right? A hammer of mass 50 grams moving at 50 meters per second strikes a nail. The nail stops the hammer in a very short time of 0.1 seconds. What is the force of the nail on the hammer, right? So here again, the hammer hits the nail, and after moving, for a short distance, the nail is able to stop the hammer in after 0.01 seconds, right? So that's what is given. So let's start with the force exerted by the hammer. Now the hammer's mass is 500 grams, which is 0.5 kgs. Now the hammer was struck with a velocity of 50 meters per second, which means the initial velocity was 550 meters per second. Once the hammer was hit, we knew that the hammer would have come to rest, right? After 0.01 seconds, it would have come to rest. So the final velocity of that hammer is 0 meters per second, and after this happened after 0.01 seconds. So this s is not distance. This is time. This s is time. So the force applied by the hammer on the nail is the mass of the hammer times the acceleration. So which is 0.5 times 0 minus 50 by 0.01. So which comes down to be minus 2500 newtons. So this is a force exerted by the hammer on the nail. But what is the force of the nail on the hammer? The force exerted by the nail on the hammer is the opposite of it, right? That's a reaction. So which has got to be 2500 newtons. So the force exerted by the nail of the hammer is negative of minus 2500 newton, which is 2500 newtons. So this is the last one. A motor car of mass 1200 kgs is moving along a straight line with a uniform velocity of 90 meters per hour. Its velocity is slowed down to 80 kilometers per hour in 4 seconds by an unbalanced external force. Calculate the acceleration and the change in momentum. Also calculate the magnitude of the force required. Okay. So the motor car of mass 1200 kg. So the mass is 1200 kgs. We know that it was moving along a straight line with a uniform velocity of 90 kilometers, and it slowed down to 18 kilometers per hour. So the initial velocity is 19 kilometers per hour, and we'll convert it into meters per second, which means we'll multiply it by 1000 and we'll divide it by 3600, right? Both the initial velocity u as well as the final velocity v. And we knew that the time is 4 seconds. So this again is not s is distance, but here it is actually time. T is equal to 4 seconds. So calculate the acceleration and the change in momentum. Change in momentum is quite straightforward, which is the mass times the final velocity minus mass times the initial velocity. So which is going to be 1200 times 18 kilometers per hour minus 90 kilometers per hour over so there's no time here, right? So it is just mass times the velocity, and it's the difference between the final momentum and the initial momentum. So this comes down, the value of mv minus mu after applying these values comes down to minus 24,000 kilograms meters per second. So this is a change in momentum. Now your acceleration is calculate the acceleration and the change in momentum. So the acceleration is going to be primarily your change in the speed over time, right? So change in speed is going to be the same value, v minus u over t, right, over 4 seconds. So this is the same value. So acceleration comes down to be this value, which is v minus u over t, which is 4, right? So it comes down to be, your acceleration comes down to be minus 5 meters per second square. It is a negative acceleration because the vehicle is slowing down. Now, what is the magnitude of the force required? Magnitude of force is going to be, your mass times your acceleration, which is, 1200 times minus 5, which is minus 6000 newtons. And since the question is just to find the magnitude, it's got to be 6000 newtons. So I think with this, we have come to the end of the second chapter. We've solved all the questions and concepts as well as the in-text questions. So I hope this was helpful, and we'll meet you all in the next chapter, which is gravitation. Thank you.
One final thing before you leave. If you wish to revise the concepts that you've just learned, please look up and try out the free Revise app bot on Telegram app. Telegram is available for free on both iPhone and Android. Also, if you did like the content that you just watched, please do like, share, and subscribe this with your friends. Thank you.